So today what we're going to start looking at are the geometric series. Now the geometric series are really pretty interesting. First of all, with geometric series, what do you suppose a geometric series is? It's what? Okay, yes? Okay, in the summation notation it would be a quadratic, is that what you're saying? Yeah, it's still a series, so you're still going to add the terms from going from term to term, but the numbers that make up the term, if you just looked at the numbers themselves, they would form what kind of a sequence? A geometric sequence. So all a geometric series is the sum of the terms of a geometric sequence. Sum of terms of a geometric sequence. Now, I know you know what it means to be a finite series. It just means that the series does what? It ends. It has a beginning and an end, right? It has a certain number of terms, 5 or 7 or 12, okay? So, if this is my finite series, and it is geometric, I don't know why I put an n there, it should be a 2. A sub 2 plus dot 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 plus a sub n, where r cannot equal 1. Now you remember with the geometric sequence, we have that r stands for our common ratio, right? And it's the number that we're multiplying by each time to go from term to term. So why do I want to say that r is not 1? Yeah. Your formula would end up just being n. Actually, it wouldn't quite just be n. What would happen if r were 1? What would happen when you went from term to term? If your first term was a sub 1 and your ratio was 1, what would term 2 be? Oh, a sub 1 again. And then what would your next term be? A sub 1 again. And then a sub 1 again. Would it be very interesting? No, it would just be a sequence made up of the same number over and over again, right? Okay, so that's why we say that r cannot be 1. If your series happens to be a geometric sequence of numbers and it is finite, there is a formula to find the sum of those n terms. And here it is. It's an S formula because it's a sum, and it's S sub n. Now remember, n just stands for the number of terms, however many you happen to be adding, and it's going to equal a sub 1 times 1 minus r to the n power all over 1 minus r. Now you just have to be really careful when you work with this formula, and I'm going to show you a few examples here in a minute. Where, of course, r is the common ratio, n is the number of terms, and of course a sub 1 is the The nice thing about this formula is, do you need to know the last term? No, that makes things, I think, a lot easier, right? Because with the arithmetic one, you had to go through and you had to find out the last term in order to use the formula there. So there is the formula. Now, what about infinite? What does it mean to be an infinite series? It never ends, right? It just keeps going. You just keep adding it over and over. You keep adding your numbers. It never stops. It has a dot, dot, dot at the end, right? So it would look like this: a sub 1 plus a sub 2 plus a sub 3 plus dot, 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 and on you go. Okay? We're going to talk about the infinite series here in a minute. Let's stick with the finite for a second. You've got does everybody have the formula down? Let's see how this is going to work. Now, your first series that you see up there, 3 plus 6 plus 12 plus 24 plus 48 plus 96. First of all, is it indeed a geometric series? Yes, because going from term to term, what do? You're multiplying by 2. Now, could you just add these up and get the sum? Yes, but I want to show you how to use the formula because it can get just a little bit tricky if you're not careful. So, how many terms do we have? 6. So we're going to look at S sub 6. So we're going to say S sub 6 is equal to, okay, the formula said what on top? A sub 1, which is the first term, which is 3, times 1 minus the ratio, which you said was 2, and what do we put as an exponent on that 2? A 6. And that's all over 1 minus 2. Now you just want to be careful. Follow your order of operations. Do the exponent first. 2 to the 6th power. 64, right? So we have 1 minus 64 up in the numerator. And in the denominator, do you agree that's just going to be a negative 1? Okay. Now we're going to have 3 times negative 63 over a negative 1. Let's finish that up. 3 times negative 63 divided by a negative 1. 189. Now, again, could you just add those all up? Sure. But I want you to see how to use the formula, okay? Because they're not always going to be a case where you're going to want to add them all up. All right? Just for fun, what if I change that into an infinite series and I put a plus dot 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 after it and I said find the sum? It would be infinity, right? There really wouldn't be a sum, right? Because it would just keep getting larger and larger and larger and larger and larger. You couldn't find a sum there. Usually, if it goes off to infinity, we say there's, a lot of times it will say there is no sum because it keeps growing. We say that it diverges, okay? All right, let's look at this next one. Is this one indeed a geometric series? Yes, with R being what number? Negative what? Is it negative 3? Is that right? Is everybody convinced that it's a negative 3? Okay. So how many terms do we have that we're summing? 5. So this time we're doing S sub 5 is equal to, okay, we need the first term times 1 minus R, what? No, because what's happening to that R? It's being raised to a power, and that's why I wanted to show you that. Okay? You really need to make sure that you follow order of operations. Now in the denominator, can I change it to a plus 3? Yeah, because there's no power there, okay? So in the denominator, I can change it to a plus 3, and I'll wind up with 4 down there. In the numerator, I'm going to have negative 45 times 1 minus, okay, negative 3 to the 5th is 3. Now can I change the position? 1 minus a negative 243? Yes. So I'm going to have negative 45 times 244 all over 4. Now, can you figure it out from there? Use your calculator and you can get your sum. All right, let's look at this one. Is this one a geometric series? Yeah, because what's R? 1/3. So let's see if we can figure this one out. How many terms? So S sub 4 is going to equal, okay, what do we put first in the numerator? 1/3, the first term, times 1 minus 1/3 to the 4th, all over 1 minus 1/3. Is everybody with me so far? You shouldn't need a calculator to do this. It's 1/3 times 1 minus, okay, what's 1/3 to the 4th? Well, 1 to the 4th is 1. 3 to the 4th is 81. And 1 minus 1/3 is 2/3. Did I do something? Yeah, you can just tell it right there. Okay, what's 1 minus 1 over 81? What's 1 minus 1 over 81? 80 over 81, right? No, because 1 is larger. Okay? And you're dividing that by 2/3, which is the same as multiplying by 3/2. This is why I said you need a calculator. Those 3's are gone. That 2 goes in there. And you get 40 over 81. There's your answer. Okay? Do you see how to do that? Be very careful when you're working with these, with this formula. Okay. Then, let's see here. 16. I want to look at this. I want to look at an infinite geometric series. Look at the one on the left. 2 plus 10 plus 50 plus 250 plus ... equals. What can you tell me about that sum? Yeah, it's going to go to infinity. What were you going to say? Exactly. The exact same thing. Okay, it just keeps getting larger, doesn't it? First of all, what's the R value over here? 5. R is equal to 5. Okay, R is equal to 5, right? And this just keeps getting larger and larger and larger. So, yeah, the sum goes up to infinity, and what we say is that it diverges. Okay? It diverges, it approaches infinity, it goes up to infinity. A lot of times you'll see it written as there is no sum because it keeps getting larger and larger. But what I'd like to do is, it's being reclaimed. What I'd like to do is look at this one over here. Would you take out your calculators for a minute, and would you go ahead and punch this in? 8 minus 4 plus 2 minus 1 plus 1/2 minus 1/4, and just put equals for a minute. Just stop at the 1/4 and put equals. And what are you getting for an answer? 5 1/4? Okay. Now, do you see the pattern that's going on? What's the next thing that's going to be added? 1/8. So now put plus 1/8, and what do you get? 5 3/8. Okay, what would be the next thing that you're going to add? Or, I'm sorry, actually subtract. Subtract the 16th. What are you getting? 5 5/16. And then you would be adding plus 1 over 32. 5 11/32. And then you would subtract, what, 1/64? Okay. We could continue this on and on and on. What do you notice is happening with the sum? Is it diverging like it did in the last example? Is it getting larger and larger and larger? Okay. Yeah, it's staying right here at 5, and it looks like this is almost, what, 5 1/3 maybe? It's pretty close to 5 1/3, isn't it? Okay. It looks like it's hanging right around 5 1/3. What was the R value on this one? Close. -1/2. What's different about the R values? Not only is it a fraction, but it is, okay, it doesn't even matter about positive and negative, the number value itself. less than 1. Since it's less than 1, every time you multiply, what is it doing to the number place? Making it smaller, isn't it? In a case like this, we say that this sum converges. It converges. It turns out that it converges if your R value is what kind of a number? Yeah. If the absolute value of R is less than 1, then the sum converges. And this only works for geometric, only for the geometric sequences. And here's what it converges to. It's infinite, so I just need an F. I don't have a little subscript down here because I'm not adding up just 5 terms or 12 terms. I'm adding up all the terms. And its formula is actually pretty easy. The formula is a sub 1 over 1 minus r. But the first thing you have to do is decide if it's an infinite series and it is geometric, you have to decide what the r value is. Because if the r value is greater than or equal to 1, maybe I should put that down, what's the sum going to do? Then the sum diverges. Then the sum diverges. Okay? So, how are you going to tell if it's infinite or not? Let me just show you a couple examples. Is this infinite? Yes, because of the ... Is this infinite? Yes, because it's going to infinity, right? On all of these, decide whether or not it's going to converge or diverge by looking at R. Okay? On something like this, you might want to write out a few terms so you know what R is. Although I claim you should be able to see it from the formula. We'll talk about that a little bit more tomorrow. Here's what I would like for you to write down. Right here is your assignment.